Good morning to Old Guy Physics, and this morning we want to talk about a review of all of the vector math that we've done, and let's go through it slow and easy and make sure that we have a good working knowledge of each part that we can do. Okay, so number one of the math skills for vectors has to do with solving for the sides of a right triangle. Now you can see over here that several of the math functions that we use for vectors involves right triangles, but you also need to remember that these only work if you have right triangles. So the very first thing that I would say to you is, if you look at this triangle right here, if we're talking about this angle with respect to the right triangle here, then this is the adjacent side, this is the opposite side, and the diagonal line is always the hypotenuse. Now, when we're dealing with vectors, we often refer to the hypotenuse as being the resultant, the results of all the vectors that are added together, okay? And it's normally a diagonal line, and we'll talk more about it as we go through it. But let's look at the very first process. A squared plus b squared equals c squared. This math function is called the Pythagorean Theorem, and it can be used whenever you are given two of the sides of a right triangle. So if I have a triangle that looks like this one right here, and I know that this side is 6, and I know that this side is 4, and I'm looking for this side right here, then the easiest way to do that is to use the Pythagorean Theorem for what we know now. So we're going to take 4 squared plus 6 squared is equal to c squared, and 4 squared is 16, and 6 squared is 36, and the sum of that is going to be 52. So 52 is equal to c squared. And then we take the square root of both sides, and c is going to be the square root of 52, which is 7.21. 7.21. And so this side right here is 7.21 units long. Does that make sense for everybody? Okay? It doesn't have to be the adjacent and opposite side. You could have it for any two sides. You just have to make sure that C is always the hypotenuse. Okay? Now, let me erase that right quick. Now, the math function number 2 that we use in the vector toolbox is called Sohcahtoa. And we learned that in a math class, and it has these 3 math functions, which is sine and cosine and tangent. And so we have to pick. It's almost like I could draw a line here and I could draw a line here. That's a math function, that's a math function, and that's a math function. And we decide which one we need based on which two sides we are being asked for, we're using in the problem. So let's take an example. If we have a problem that looks like this, and that's a 40-degree angle right there, and I have this side is 6, and I'm being asked what's the length of this hypotenuse on this triangle? Well, then I'm evaluating what two sides are involved, and we know that this is the opposite side because it's across from the angle. And then we know that the diagonal line is always the hypotenuse. Well, once we identify opposite and hypotenuse, then we look at our 3 math functions, and sine is the opposite over the hypotenuse, which is also over there at the top. And so we're going to write the formula. Always write the formula and then substitute the numbers in second. So we have the sine of a 40-degree angle over 1 is equal to 6 over h. And we're going to use h for the hypotenuse. The reason I put a 1 here is so that students will remember that they need to cross multiply. So when we do that, we're going to cross multiply here and here, and we have the sine of a 40 times h is going to be equal to 6. And so you take your calculator and you find out the sine of a 40-degree angle, and the sine is 0.643. And I usually keep 3 significant figures when I'm doing sines and cosines and so forth. And so now we have 6 is equal to 0.643h. So we're going to divide this side by 0.643, and we're going to divide this side by 0.643. And h will, this cancels, and h ends up equaling 6 divided by 0.643 is 9.33. 9.33. And so the hypotenuse is 9.33. Now, most of the time when you're using Sohcahtoa, if you look at this problem, they've given you an angle measurement and they've given you a side, and they're asking for another side. But there is also a possibility that they could ask you for an angle measurement. Let's look at one of those right quick, because that one is the one that requires you to do the inverse or the second function on your calculator. So let's do one that looks like this, and let's make this 4, and let's make this 5, and they're asking for that angle right here. Okay, so again, we evaluate the sides. We see that this is the opposite side that they've given us, and this is the adjacent side that they've given us. When we look at Sohcahtoa, opposite over adjacent shows that we need to use the tan function. Great day. Here we go. So the tan of the angle over 1 is going to be equal to 5 over 4. Now, on a TI-83 or 84 or one of those types of calculators, the calculator actually allows you to enter a fraction, so you're good to go. On my old calculator, I've got to actually calculate it out. So 5 divided by 4 is 1.25. So 1.25 is equal to the tan of the angle. Now I don't need, the tan of the angle is this, but I want to know what in the world is that angle. And so the way that you solve for that is that you hit, I'm going to draw it out right here, second tan, and then they'll give you a parentheses like that. You plug in 1.25, or on your calculator you could plug in the fraction 5 divided by 4, and it will automatically tell you what the angle is that corresponds with that tan. So let's do 1.25 and inverse tan, and it says it's 51.34 degrees. So that angle right there should be 51.34. Now, I just thought of something, and it might be important. In my class here at LCA, I've already tried to encourage all students to check this. But if you were working this problem right now and you did not get 51.3, there's a very good chance that your calculator is not set up in degrees. So if you have a TI-83 or an 84 or 84 plus or whatever, then what we need for you to do is to hit the mode button on that 83 or 84, and you need to look at go down to the third line and see whether degrees or whether radians are highlighted. You want the word degrees to be highlighted, so you move the cursor over degrees and then you hit enter, and that'll set your calculator up in degrees. And then run that calculation again and see if you don't get 51.34. Okay? Now, I've said all those are the simplest ways that we did some of these things. But then we did some labs, we did some vector drawings and stuff like that, and they look like this. and we're going to talk about some different things that we could use to solve it. I had one that said 5 east, 6 south, 3 east, 4 south, and then let's go 2 west. And this describes a pathway that someone has taken, and then we're asking them to solve for the resultant. Now the resultant in this situation would be the displacement, the distance from starting point to ending point. And so if we establish an origin here, then we're moving 5 units in this direction, and then we're going to go 6 units in this direction, and then 3 units in this direction, and 4 units south, and then 2 units west. Well, after you've drawn this diagram, and let me encourage you to draw these to scale. I'm just sketching them out, so it should look similar, and I'm trying to draw it somewhat to scale, but when we actually draw vector diagrams, we want them to be measured out where every centimeter equals a certain value, and we're drawing them to scale. Another way of doing vector diagrams really good is to use graph paper, and then you can use the boxes on there to represent a certain value. Now, if I draw this diagonal line right here, that diagonal line represents the resultant. The resultant is also referred to as the hypotenuse of the triangle that I need to solve for. And I'm going to change colors right quick so you can maybe see it a little better. I'm interested in the triangle that's formed here or the triangle that's formed here. Now, one of the things that we talked about in class a bunch is that whether it's this triangle or whether it's this triangle up here, they're congruent, because when you take a rectangle and you cut it in half from corner to corner, like we just showed, what the diagonal line is doing, then these two triangles should be congruent. Now, what we're going to use is the measurements that for the walk are going to help us to solve for the length of the sides of the triangle. And so I went to the right 5 and I went to the right 3, which is a total of 8, but I came back 2. 8 minus 2 would make this side right here 6. Does that make sense? And then we came down 6 and we came down 4, so that makes this side right here 10. Now another geometry term I'm guessing is that if we're interested in this angle here, we know that that's the same as this angle here. Those are congruent angles. And so here I have an x equal to 6 and I've got a y equal to 10. Another way of looking at that is I have an adjacent side that's equal to 6 and I've got a opposite side equal to 10. And so I'm interested in what's the length of my hypotenuse and what is the angle that forms as a result of those two things. Now, let's run it the old way. I say old way, let's use Sohcahtoa right quick. We've got the tan of the angle over 1 is equal to 10 over 6. Well, 10 over 6 is 1.666, repeating like that, is equal to the tan of the angle. So that angle is going to be the second function tan, 59 degrees. So we know that that's going to be 59 degrees. So right here, this is 59 degrees. Now, if we want to go old school, we could do a squared plus b squared equals c squared. So we've got 6 squared plus 10 squared is equal to c squared. This is 36. This is 100. So the square root of 136 should equal c. And 136, take the square root, 11.66. 11.66 should be this side right here, 11.66. Now, in class, we learned a new technique called rectangular to polar, or polar to rectangular. And in my class, you can find that on your TI-83 or 84 calculator by hitting second function apps. There's a little button on the calculator that says apps on it. And the second function above apps is angle. So when we hit second apps, we're actually getting functions for solving for angles. And there are 4 different computations there that we want to try to use. There is 5 and 6 and 7 and 8. And if we have the, let me grab one of these calculators so I can show you exactly what I'm talking about. We're going to turn that baby on, and it's second apps, and then 5 and 6, it says R to PR and R to P theta. What that's saying for these two functions right here is I have the rectangular coordinates. I have x comma y, which we've already seen that we have over there. And if I plug in x comma y, it's going to give me the resultant. It's going to give me the hypotenuse. And if I plug in x comma y here, it's going to give me the theta. It's going to give me the measurement for the angle. And so this is that new way that we worked in class, where if I have the x and y values, it will give me the hypotenuse and the angle. Now, 7 and 8 works it backwards. Suppose that it gives you the polar coordinates, which we'll talk about in a second. It's going to give me r sub x, and polar coordinates to give me r sub y. And what 7 and 8 does is it takes the polar coordinates and converts it back and tells us what x is. And the polar coordinates, it tells us what y is. And so the polar coordinates look like this. It's going to be r comma theta, like that, where r is the hypotenuse, and I'm going to write that right here. Hypotenuse, comma, angle, like that. Now, just for your personal information, if you look at your calculator screen, you see me entering commas. The comma is the button that's right above the 7 on all your TI-80 calculators. Okay, so we can run polar to rectangular, and that eliminates the use of tans and cosines and stuff like that. And a lot of the students found this easier. It doesn't mean you don't need to know how to use tan and sine and cosine. This is just another tool in the toolbox. Okay, and so it works like this. I could go 6, comma, 10, and then rectangular to polar. And again, I got 11.66. And then I hit the rectangular to polar again, and it tells me it's a 59.04 degrees. And so this works, and this works too. You could always use, if you're not comfortable with this, you could always go back and double check your answers here. But you should be able to go back and forth between these two different math functions, and you should be able to get your answers, and they should complement each other. You should see that they're both giving you the same answers, and that will build your confidence in working those problems. If you have questions, don't hesitate to come and see me about this. Now, the last of the toolbox that I want to talk about has to do with vectors that go off at angles. And the review sheet that I gave today in class looked like this. It went out a value of 6, and then it went up a value of 7 at a 40-degree angle. Okay, and so and let me put another one in there. Let me go up 4, like that, okay? And so we're interested in the diagonal line that creates the big box here. So we've got an angle here, and we've got resultant or a hypotenuse here that we need to solve for. And I was showing the students that here I have a hypotenuse at an angle. Let me change colors again so that you can see this more clearly. I told the kids in class yesterday, I said, you got to look outside the triangle. And that's exactly what I meant. If you come over here like this, you get X. And if you come down like this, you get Y. And now you can see the big triangle that creates that hypotenuse that we're looking for. But we got to solve for this smaller triangle first. Okay? So when we do that, we've got a R and theta, so we're going to go polar to rectangular, and we're going to solve for the X and the Y. So I've got 7 at a 40, and polar rectangular gives me 5.36 here, and 4.5 there. Rounds off to 4.50. Okay, so now, let me move this 6 right here, makes it easier to see. This line segment to right here is 6. This extension is 5, so the sum of those is 11.36 along that x-axis. And the y value is 4.5 to here, and then from here to here is 4, so the sum of those is 8.5. Whoops, I know my 5s look a lot like an S, I apologize. So now I have a x value, total x, and I have a total y. Well, now I can go right back, rectangular to polar, and I can solve for that new angle and for that new hypotenuse. And let's run that right quick. 11.36, second function, x to y, 8.5, and rectangular back to polar, 14.19 is right here. And the angle is 30, that's not a 3, 36.8 degrees. Now, if you could do that for one of the triangles that's kind of outside the box, so to speak, it doesn't matter how many of you have, you just keep making those right triangles and solving for those other x and y values to complete the big triangle. And that should help you out. Now, that is about all the examples that I have for you today. If you still need additional help, you know that I'm here before school, and I'll be glad to help you. I appreciate you watching the video, and you guys have a blessed day.